part 2. Basically what we're going to go over is just a couple of different indeterminate forms and another algebra technique just to make sure you got it. So, let's check out you ran into something like this on your homework if you started on it. You got far enough. I advise you to get very comfortable with using H. This is going to come up a lot the next month or so. It's a variable. It's just a variable that we use in specific cases.
Yeah. Variable one because I'm thinking X all the time.
I know.
So switch to variable.
Okay, David. Plug and chug.
Oh, it's
No, plug and chug. We have to make sure it gives you an indeterminate form first. Bob is. Autumn is. 5 plus 4 is 9. Okay. So you get an indeterminate form, right? Now we can algebra it. What are some thoughts you might have on this? Inverse?
so you should multiply the top and the bottom there. So it's h plus 4 plus 3, because then you get the square root of h plus 4.
Yes, correct. It's not called an inverse, it's called a conjugate.
Yes.
We want to multiply by the conjugate, top and bottom, because it usually gets rid of the issue that we're having with the indeterminate form.
Wait, you do h plus 4 still? Not h minus 4?
Yes, it's only you only change the middle sign. This you can use this when you can't factor. Yesterday we saw one where it was like root x minus 2. We could factor that. This is not factorable, so but you use the conjugate multiplication. Okay. Every time you drop a line or set an equal sign, keep the limit. Okay? Yes, really. So if you drop it, that's not an equivalent statement. Keep this on here. What's the top going to be now? That's a mess. How about we just leave it? It's the best idea I've had all year. My guess is we're not going to need to multiply that out. We don't need to use the time. The bottom is what we need to worry about. We might have to multiply the top out. Oil. First times first gives us h plus 4. Outers plus 3. Root h plus 4. Inners. Oh, look at that. You see something very special here. This is our intent with the conjugate multiplication. This game's wild. Yeah.
I'm not sure quite how this is going to go. H with the bottom. That would be h plus 4 minus 9. I think that goes into h minus 5. So just made it more easy to
We've set you up for success. You cancel, and now you plug and chug. Six.
What? Because isn't 5 going to 4?
5 plus 4 is 9. 9 is 3.
Positive.
So multiplying by the conjugate can sometimes be very handy. Just remember to be precise on your algebra. When you multiply those out and stuff, be precise on your algebra.
Imagine like NASA.
Here's one more. We'll talk a little more about infinite limits, but if I plug 1 in, I get 1 over 0, correct? But this is approaching 1, so we got to think that smaller and smaller decimals are going in here in the denominator. What number is this approaching? These smaller and smaller numbers in the denominator. What are we going to? That's it. This, right? So this is actually an indeterminate form of this matrix. So think about it. 0.01 is 100. 0.02 would be 1,000. 0.03 or right, 0.001 would be 1,000. If you keep going decimals and expanding in 10,000, 100,000, it's going to infinity, correct? So that's what we're looking at here. Okay. Kind of sounds funny, but we'll study this more deep in a few days. Now I can algebra it, because that's an indeterminate form. Any thoughts on these two? If you were in pre-calculus, what would you do with these two fractions? You combine them with a common amount right here. So I'm going to leave a space there for a reason. So I factor there. What do I need to put here? Yeah. So now I have a common denominator, right? What's the top going to be? X plus 1 minus 2. That is minus 1. Guess what? We can cancel out. We already have it in the denominator. We don't need to put it back. So we want these to match. Right? So this is an x minus 1 and x minus 1 doesn't match. Right? So said an X plus 1? This does not. So we put an X plus 1 here, top flow. Got it? Okay. All right, good there? Just, again, more algebra memory got it. What about it? Yeah, we did. X plus 1 minus 2. Plus 1 minus 2. Same thing. X minus 2. I heard someone say it, so I figured I'd okay. Let's talk about one more. 2 more. Be very careful. Sometimes you're going to get a limit like this one. What's our first step again? Okay, what do you get? Because it's not an indeterminate form. So be very careful. Don't do any algebra here. This is where a lot of people trip right off the bat when they're evaluating limits. So if you get something of this nature, this limit probably does not exist. It's an infinite limit. Right? Think about